Good evening, everyone. Welcome to the live session. Today, we'll be discussing practice problems from week 8's content. For a brief introduction, I am Poulumi. I'm one of the TAs for the NPTEL Natural Language Processing course. We'll be waiting for 5 minutes for everybody to join in, and we'll be starting at 7:05. Okay, good evening, everyone. So, let's get started. So today, first we'll be discussing one of the doubts that were asked in the last class. So we'll be understanding the data-driven approach for the transition-based dependency parsing. So we'll go over that problem first, and then we'll take up further practice problems from week 8's content. Okay, so let's see what the problem is. We'll be directly reading the problem and directly jumping into the solution for this one. So here what we are given is, so here we are learning a classifier. So the classifier is for the transition based parsing we're doing. And we're using a data driven deterministic parsing approach over here. What is the sentence that is given to us? The sentence is, I prefer ChatGPT course. Okay, and we assume that this is a gold standard pass in the training data. So what does that mean? So I also have the corresponding gold standard dependency pass available with me. You're also given that ChatGPT and course are nouns. So the part of speech tags are given for each of the words that are there in my sentence. So ChatGPT and course are nouns. I is a pronoun and prefer is a verb. So we need to obtain the dependency graph first. We need to do that ourselves. We'll see that in a minute. And then these are the few four features that we need to take into account when when like when coming when going from the configuration to the corresponding feature vector. Okay, and so these are the four things. Next is we have been given the initial weight that we need to start with. So we are not starting with the vector of zeros in this case. We are starting with this set of vectors. And so one thing to note over here is the order. So the first four numbers over here, they are the corresponding features corresponding to LA, that is the left arc. The next four corresponds to right arc, then the next four for shift, and finally we have the last four elements in this weight vector corresponds to reduce. Okay, so here the question is what will be the weights after completing two iteration of arc per surpassing over the sentence. So that is the question. Okay. Um, okay, let's see. So this is the algorithm that needs to be followed. I just kept it over here as a slide. We'll be referring back and forth to this as we solve the problem. Let's right away jump into the problem. So first is we need to design the dependency graph. So this is a sentence that was given to us. I prefer ChatGPT course. So what would be the corresponding dependency graph? Prefer would be the root. So from the verb to the corresponding subject, that is I. So I have the dependency arc present over here, one of these. Another one is from the verb to the object, the direct object in this case, which is course. And here ChatGPT is acting as a noun modifier for the word course. So here I have one more arc. So in this phrase, course is the head, ChatGPT is the dependent. Okay. So let's design the features. So given a configuration, I need the corresponding feature, and the feature is a function of the of the choice, that is this one, the conditions that are given to us. Along with that, the transition. Okay. And here we ensure that each of these we are making we are repeating it. We are making four copies for each of the conditions so that it is independent of the transition that we have. So for LA, corresponding to the four conditions that we have four vectors. So C1 and LA means the first condition is satisfied, and the current transition that we are performing is left arc. Similarly, condition 2 and left arc, condition 3 and left arc, and henceforth. So we carry on like this. So similarly, we have to do the same thing for the right arc transition, for shift transition, and for the reduced transition. And this is my initial weight that is given to us. So now what we need to do is, given the sentence, I first need to start with the initial configuration, which is this. The configuration has three elements, that is stack, which would be empty initially. I have the buffer, which consists of all the words that I have in my sentence. In this case, it is I prefer ChatGPT post, and the set of arcs, the set of transition arcs, it's empty at the when we are starting with the algorithm. Okay. So now we looked upon this the f of c comma t, which is the features. We looked upon how to what each element would designate in the last slide. Now, based on the conditions that are given in the question, we need to find the value for each of the arcs. Okay. So what is f of c comma la in this case? So my current configuration is this, and the arc that the transition that I'm currently performing is left arc. So let's see the first values. The first value is the stack is empty, and the corresponding transition is left arc. Yes, this is satisfied, so we have a corresponding value of 1 over here. And let's see the second condition. The second condition is top of the stack is now, and top of the buffer is verb. Okay, so this condition is not satisfied because the stack is empty, so there's nothing on the top of the stack. So this condition is not satisfied. So we have a 0. Next we have the top of stack is pronoun and the top of buffer is verb. Okay, this is also not satisfied, which gives us a 0 over here. Finally, the last condition is the word at the top of the stack occurs before the word at the top of the buffer in the sentence. This is again not satisfied because there's nothing in the stack, So the second, third, and fourth conditions would all be 0. And so that is why we have these three zeros here. Now, once these first four elements was for left arc, remaining are for the remaining transitions. So right arc, shift, and reduce. So just because we are handling the left arc transition in this case, automatically the remaining these set of vectors would be 0. Okay. Now let's.
One second.
Yes.
This current configuration, we take it as an initial beginning of the.
Yeah, because we are starting with the algorithm, right? Because of that. So this is the first step in the algorithm. So that is why the current configuration would be the initial configuration.
But they are given initial weights that is nothing but the current state.
Uh, just a second. What are you saying? The initial weight you're saying?
Yeah.
So this is the weights that you start your start your algorithm with. So in the video lectures, I think sir had mentioned to start with a vector of zeros. Uh, Here the case is a bit different. We are starting with a concrete set of numbers over here. But this is the weight we start our algorithm with, our training algorithm with.
So the feature conditions and the current state, there is no relation.
Feature condition and current state. No, 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 not like that. No, there's no such correlation. So this would evolve. I think so. We are going to perform two iterations of the algorithm. I think your doubt would eventually be cleared. Just yeah. Okay. So let's see the for the remaining of the transitions. So in transition based dependency passing, we know that we have four set of transitions possible. We saw what happens in left arc. Now let's see what happens in right arc. So in right arc, similarly, so the first four corresponding to left arc, those would be evaluated to 0. Now for the next set of four elements, these correspond to right arc, and for these I need to evaluate each of the conditions and see which of the ones are getting satisfied. Okay. So here we see that given my current configuration, the stack is empty, yes, and I'm performing a right arc transition. So this is correct. And so, I mean, this is true. So we are having a value of 1 over here. Okay. And if we similarly go over the other conditions, we'll see that those again evaluate to 0 again simply because of the reason that the stack is empty. Okay. Again, just to reiterate, so the next set of 8 zeros, the first four corresponding to shift and the next four corresponding to reduce, but we're handling right arc in this case, so those would be 0. Okay. Similarly, if you go over to shift and reduce, we'll see the same values would be emerging. Just so the first in the set of four elements, the first one would be 1, the rest of them would be 0, and similarly for reduce. So doing this, I get the value of my feature vector at this current configuration. So till where have I reached? So this was my configuration. From there, I have reached to the feature vector. Okay. Now the next step is I need to check, I need to do my weight update. How do I do that? So this is the initial weight that was given to me. Now I need to see, given this current set of weights, what is the optimal transition that is being predicted by the classifier. Okay. So how do I do that? I multiply the weight with each of the features that I obtained. Okay. So let's see one by one. So I'm multiplying the weight with f of c comma la, which was this one. Okay. And what do I obtain upon multiplication? So all of them are 0. So all these get to 0. Only the first elements are getting multiplied and we get a value of 2. Similarly, I do the same process for the right arc, shift, and reduce. I get the corresponding values of 3, 2, 2. Okay. So these are what I get. So based upon this, I need to see which of the so based on these, I need to see that which one is the maximum value. Okay. So I see that the arc corresponding to right arc gives me the maximum value. I think someone is unmuted. Just
Yes, sorry, ma'am. If at all these values are
Hmm.
all are equal values, then all max any order to take it,
If they're all equal, then I
or it's
think,
also resulted in two, right?
okay, I got it. You're saying all of them would be two, right? In that case, you can make an arbitrary choice. You can make a random choice. There's
Yes,
no specific priority order. Okay, is that
okay.
okay? Yeah.
Yeah,
So in this case, what we see is, so the right arc gave me the maximum value in this case. So the current classifier with this current set of weights is predicting that for the current configuration, the best transition that I should take is that of right arc. However, we also need to see that what is the transition that is being predicted by the oracle. So if we look at that, we'll see that the current transition is shift. Why is that? We had discussed this previously when we were discussing week 6 practice problems. So currently, we'll see that whenever we are making, whenever I'm determining that which transition I should take, I always check what is there on the top of the stack and top of the buffer. So we see that since top of the stack is empty, no left arc or right arc transition can be performed at this particular step. So even so, and there's nothing in the stack to reduce further. So reduce is also not possible. So I'm only remaining with shift. So shift is the only feasible transition that I can take at this current point, at this current configuration. So that would be the gold label. Okay, that would be the uh, correct transition at this step that is given by the oracle. Okay. So this is the true value, this is the predicted value. And I observe that the predicted value is mismatching with the true value. So we need to perform a weight update, which is as per this formula. Okay, then let me just quickly go over to the algorithm. So we are at this step. Okay, we predicted the transition. Okay, using this formula, right? We calculated weight into each of the features vectors for all possible transitions, and we took the maximum one to be the predicted one. Okay, this we did. We also saw what is the transition that is predicted by the oracle. So these two we have done. We see there's a mismatch. Now as per this formula, we perform the weight update. Okay, so the formula states that what would be the new weight update? It would be W old plus f of c comma t0. T0 is the transition stated by the oracle, minus f of c comma t star, the predicted transition. So what would be the values in this case? So it would be w old plus f of c comma the shift minus f of c comma ra. So w old is this one. Okay. F of c comma sh is this part, only this part, or you can observe it from the previous slide. So this part, okay. So I'm adding that and I'm subtracting the ra1. Okay. So as a result of this, what do I get? I just, so 1 gets added over here. So this becomes 3 and 1 gets subtracted from over here. So this gets 2. Okay, so these are the, so this is the final weight vector that I obtain after this one step of iteration. We'll be doing one more step of iteration after this. But till this point, does anybody have a doubt? Okay. Okay, let's go over to the next iteration then. So what would be the next step? So now I need to perform this transition, the shift transition, okay? Because you see, in this step of the algorithm, what do I do? How do I go to the next configuration? I take the transition that was predicted by my oracle, okay? And what was that? That was shift. So this was my configuration. I perform shift. What happens? I goes to the stack and remaining prefer ChatGPT post remains in my buffer. And so the arc would also be empty. So this is my current configuration right now. Okay, well, I is there in the stack and as I stated, so the remaining 3 was in the buffer. Now again we need to find the values for each of the features. Okay, each of the features for corresponding to each of the transitions. So here um, let's see for the left arc. So the first condition is the stack is empty. Is the stack empty? No, it's false. So we have a 0 over here. The next condition is the top of the stack is noun and the top of the buffer is verb. Is that the case? No, the top of the stack is not a noun, it's a pronoun. So this is again false. Third condition is the top of the stack is pronoun and the top of the buffer is verb. Okay. So the third condition, C3, it is evaluating to correct and I am performing a left arc transition. So both this is true, true and true. That gives me overall I get a value of true, and so I have a 1 over here. Similarly, next let's see the next one. So this the fourth condition is the word at the top of the stack, which is I, occurs before the word at the top of the buffer, which is prefer, in the sentence. It's saying that does I occur before prefer in the sentence? Yes, it indeed does. So so this condition C4 evaluates to true, and I'm performing a left arc transition as determined by this. Okay, so here we again have a value of 1. Okay, and for the remaining ones I'll have a value of 0 because I'm currently evaluating left arc, whereas for the other elements in the feature vector they corresponding to other possible transitions that are there. Okay, similarly for right arc we would have a very similar thing. Let me just briefly say it. So first 4 would again be 0 because here we are dealing with right arc, but these are features corresponding to left arc, so these are 0. Next is again same thing, the stack is empty, false, this is 0. Top of the stack is noun, no, false, so this is again 0. Again the top of the stack is pronoun and top of the buffer is verb, correct. And I'm performing a right arc transition, yes, so true and true, I get a value of 1. Okay, similarly I get a value of 1 because I occurs before prefer, that was the fourth condition, and so this also evaluates to 1. Okay, and remaining are zeros. So similarly, we have to obtain the feature vectors for shift and reduce. And it would be very similar. So you're just the same set of 4 values would be now shifted to shift and reduce. The remaining all would be zeros. Okay. Till here, I obtain the feature values corresponding to this configuration. Okay. From the configuration, I now have the feature vectors. Next is I need to find out what is the transition that is being predicted by this current by the classifier with the current set of weights, which is this. So what I do is I again multiply this weight with each of the features that I obtained. Okay, so these features that I obtained. Suvarna has raised her hand. Yes, Suvarna.
Yeah, yes, ma'am. Am I audible?
Yes, you're audible. Go on.
Okay. So this will always happen like right. Whenever we calculate the feature vectors for all these four operations, so they will be uh, similar to each other, right? Like 0, 0, 1, 1 we have for left arm, then right arm, shift and reverse. So they
So
will always be same.
so it's how we have designed the feature. You see, you currently see where I'm hovering the mouse. You see how we have defined f of c comma t. So we
Yes.
have for the same condition, say C1, once I'm associating it with LA, once with RA, once with SH, and once with RE. So irrespective of so forget about the transition. So C1 would be true for any specific configuration. Okay. So for example, in this one, C1 was true if the stack is empty, irrespective of whatever transition I'm taking, right? Stack is currently empty.
Yes.
So because of that, so with whatever transition it appears with, so C1 and LA, that is one, C1 and RA is one, C1 and SH is one, and C1 and RE is one. Because C1 itself, the condition itself was true in this particular configuration.
So this formula for like f of c comma t, this will be this only this formula we have to use for all the questions of this type, right?
Yes.
Or we we will be defining it. It will depend on the question that we do.
No, like this itself you have to define.
Okay. Okay.
Yeah. So here, so we
Transition can change in the formula, right? Here it is the arcs they have given. But
uh,
feel that the order of the order also is something in the question.
order, you have to follow the order that is given in the question. Yeah.
And actually, in actually T itself, R3, I introduced a root here.
Here,
Yeah.
here. Um, yeah, you can do that, but so when we're talking about a dependency, it is from a head to another. So um, I mean, you can do that, but I don't think we're taking that into account in the algorithm.
Actually, with that, it is going wrong here.
Okay.
Because the word WJ occurs before WIML, we use for a different value.
Okay. Yeah, got it. So I think maybe in this, when you're um, training the classifier, I think you can you may omit the root as well because it's implicit somehow. So always the verb, the main verb would be the root of the sentence, right? Yeah. So here we multiply the weight with each of the feature vectors that we obtain for each of the transitions. So what value we get? We get these set of values 4, 5, 4, 4. Here again we are seeing that the classifier is predicting RA. Okay, RA to be the optimal transition at this current configuration. However, if we see what is the transition that was predicted by the oracle, that would be a left arc. Why so? Because you see that the word I, which is there on the top of the stack, and the word prefer, which is there on the top of the buffer, they have this relation. See, so this is a left arc relation. So that is why at this current point, the ideal transition is that of a left arc. However, our classifier has wrongly predicted it to be right arc. We see that there is a misclassification here. So based on that, what we see, we just then plug in the values in the formula. So W old is this one, okay. WLA is this one, and RA is this one. So finally we obtain this. How? We are just adding 1 1 over here. So that's one change. This is becoming 3 3. Another one is we're subtracting 1 1 from here. So that becomes 2 1. So via doing this, we obtain this is the weight vector we have after 2 steps of the iteration. Um, so yeah, so this was the problem. Do any of you have any doubt?
So each iteration we have to see as per intuition what is the optimum, what we arrived at.
Mm. So yes, as per intuition, as in so remember we had done a similar problem when we were discussing week 6 practice problem. So there's a so at each step, say shift, then left arc. These things you first have to maybe run and see what is the correct one at this particular step. Okay.
So we should derive the arc transitions before starting the problem so that we know.
Yeah, what is the gold label? What is the gold transition? Yeah. Any other doubt? Anyone? Because it was asked in the question. So the question asked what would happen after 2 iterations. So that's why. Anything else? So it's a bit of a like there's a lot of computation in the problem. If any step is confusing to any of you, we can go over it again. Just let me know. You can unmute yourself and yourselves and ask. Or else we'll go ahead with this week's practice problems. Is this clear to everyone?
So basically, in that, um, initially we start with the initial configuration that is type is empty,
Yeah.
whatever the question.
Yeah. How did I get 4544? Okay. Here. So the weight that I have at the current iteration is this one. So what we are trying to do over here is we are currently at this step of the algorithm. Okay. Where we see that there are still elements in my buffer, so I still need to further run my training algorithm. I'm currently trying to compute what is the predicted transition as determined by the weight that the classifier has, and so an f of c comma t, which is the feature vector corresponding to my current configuration. Okay, and we compute for each of the transitions. So what are the transitions uh, in my transition based dependency passing algorithm? It's left arc, right arc, shift, and reduce. So for all four values of the transition, I compute this. Okay, weight multiplied by the corresponding feature vector, and then we see which is the maximum one, which transition is giving the maximum value. That would be the predicted transition. So that is what we are doing over here. If you see that, so these are the four transitions that I just mentioned. Okay, and we are multiplying the weight value, which is this one, with each of the feature vectors that we computed. Okay, I hope you understood this. So we are just multiplying those. So we are multiplying this with this, and we see that so this is 1 1, so others are all 0, so only these two are the ones which are there. So 2 plus 2 would give me 4. Similarly for RA, I have 1 1 here, so 3 plus 2 is 5. Similarly again 1 1 and 1 1, so that is 4 and 4 here. Now we see which is the maximum one over here, which is 5, and what is the transition that gave me this maximum value, which is RA. So that is the predicted transition over here. So that is T star. Does that clear your doubt, SS Bharti? Okay. Uh, Amit is asking if anyone can share the uh, link of the discussion forum. I think it is there in the portal itself. When you log into the NPTEL course, there is the discussion forum present. Otherwise, maybe somebody, any of the students, maybe if any of you can just provide the link to Amit, it would be helpful. Um, any other doubts related to this problem? Okay, then we'll go over to the uh, practice problems for this week. If anybody has a doubt, you can come back to this later then. So this is the first practice problem for today. We have been given two sentences, okay, and we need to find the relation. So sorry, the words have not been highlighted. So the words would be bank in this sentence, and this one it would be right and right, okay. In the first sentence, the words are right and right. The second one is bank and bank, okay. These are the highlighted words in the sentences, and you need to tell what is the relation between these set of words, okay. So please take a second to try solving this problem. And please, once you're done, please post your solution, your answer in the chat, and we'll discuss it in a couple of minutes.
Do you see the highlighted words in the sentence?
No, 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 I have missed that. So the first sentence, the highlighted words are right. Just a second. This right and WRIT right and RIGHT right. Second one is this bank and this bank. Okay, so great. A lot of you have tried answering this. So let's hear from some of you. Um, so Ashutosh has mentioned that it's option A, homophones and homonymy. So Ashutosh, would you like to share your thoughts on how you came about the solution? Yes, you can unmute yourself and you can say. Okay, let's hear from someone else. Suvarna, how about you? You have also said answer A. So everybody thinks it's answer A. So um, let's hear from Suvarna.
Yes. So in first sentence, the words that we have to consider are WRIT right and RIGHT right. So both of these words they have different spelling, that is orthographic properties, but their pronunciation is same. So such words they are known as homophones. And in the second sentence we have bank and bank. These two words have same spelling, but the meaning over here in both the cases is different. So such situations, such words, they are known as homonyms.
Yeah, correct. Correct. Um, so, so okay. Let's. So why not? So that was correct. So let's just go over the other options as well. So why not hyponym? What is a hyponym? Can anybody say?
Where it can be categorized into subclass and class.
Okay, so hyponym is the subclass or superclass. Which one? Yeah, correct. Um, okay. All right, let's discuss. So it's correct. So the answer is A, as all of you have mentioned. Let's just briefly discuss the associated maybe theory ones. So corresponding to a lexeme, there are two things. One is the form part, and another is the sense part. So what is the form? Form has two things. It could be the orthographic form and the phonological form. Orthography is the way we write it. Phonology is how we pronounce it. Okay. So orthographic form and phonographic form, they constitute the corresponding form part of the lexeme, whereas the lexeme's meaning, that is what that is what is referred to as the sense of the lexeme. So lexeme has two things, form and sense. Now, based on these, there are different lexical relations between different set of words. One is homonymy. So in homonymy, what happens is the form is same corresponding to the words. However, the meanings would be unrelated. So here we see words such as bat, where bat in one case means the bat with which we play cricket, possibly, and another one is bat, which means the flying mammal. So in this case, we see that the orthographic form is same in this, and however the meaning is different. So homonymy includes both things. It includes so same form can be same orthographic form, or it could be the same phonological form. Okay, so based on that, we could further classify homonymy into two things: homophones and homographs. Homophones are the words which have the same pronunciation but different spellings, such as right versus right, the one which we saw in our question itself, or peace versus peace. Another thing is homographs. Homographs are lexemes which have the same orthographic form but different meaning. So here we have the word bass, which means so in one case it's related with the music, I guess, and another one is I think I another
Fish.
fish. Yeah, correct. Another one is fish. Yeah. So it's the same spelling but associated with two different senses. Okay. So these are the two things. Next is hyponymy. So what is hyponymy? So we have hyponymy and hyponymy. Hyponymy is the subclass, hyponymy is a superclass. What does it mean? So one sense is a hyponym of another if the first sense is more specific and subclass of another. For example, dog is a hyponym of animal. Even cat is a hyponym of animal. Mango is a hyponym of fruit. Whereas if we reverse it, fruit is the hyponym of mango. Okay, fruit would be the superclass and mango is the subclass. So, so this way is the hyponym relation. This way is the hyponym relation. Next we have synonymy. So synonymy we all have studied since we were in school, I suppose. So what are synonyms? Synonyms are words which have the same meaning and same meaning in some particular context or all contexts. For example, such as couch or sofa, big or large. So these are examples of synonymy. And what is polysemy? Polysemy is so the words that would be associated, they would be very similar. They would have very similar meanings, such as we see these two sentences here. The bank was constructed in 1985 out of local red brick. Here, what does bank signify? Here, bank means the building that is associated with the financial institution of the bank. Whereas, if I say I withdraw the money from the bank, your bank itself refers to the financial institution. So there's a very subtle change in the meaning. So if we can discriminate the sense of two different lexemes at this very subtle granularity, then those are policy. Those constitute policy. So these are the different lexical relations that we can come across. Does anybody have any doubt? I suppose not. Okay. So let's go on to the next question. So this is a very similar problem. So please try answering this. We'll discuss it in a few minutes. So I think one of you had asked a question. So I think Praveen had asked what is troponym. So as far as I remember, troponym is like so there would be two lexemes, and one signifies a particular way or a manner of doing one particular thing. Um, say for example, maybe a manner of eating or a manner of or a way of walking like that. For example, if you're staggering and walking, that could be an example. Or if you're like uh, so different ways or different manners of walking or different manners of eating. Those would be, so if there are two lexemes which where one sense is a manner of another one, or a way of doing another lexeme, that is troponym, I think. Um, Other than that, okay, so so some of you have answered this question. Um, so the majority answer that you have given is A and B. Okay. So, hmm, okay, let's hear from Mradul. Maybe Mradul, why do you think A and B are the correct answers?
Yes, I will first statement the dog is a subclass, so that means it belongs to hypernymy. And in second statement, that fruit is a superclass. So that goes into hypernymy.
Yeah, correct.
C and D are just
Correct. Yeah, correct. Um, so yeah, that was correct explanation by Mradul. Let's just have a see. So the official solution is A and B, and why we discussed it previously in the first question as well. Even Mradul explained it. So I think so we are done with this problem. Anybody has a doubt? Okay. So here we are given. So this is the third problem for today. So here we have two concepts and their glosses are given. So the concepts are currency and money, and these would be their glosses. Okay, so we need to find the similarity score between these concepts, currency and money, and we have to use the extended list algorithm in this case. And so extended list, we need to find the common words. We do not need to consider the stop words. Okay. Other than that, we need to find what are the other words that are there, and we need to solve the problem. So please try this problem, and we'll discuss it in a couple of minutes. So only one of you have answered the question till now. Is is the question clear to everyone? Does anybody have a doubt on the question? Okay, so are any of you still solving the problem and would like us to just wait for a couple of minutes?
Ma'am, what are the common words that we need to consider here?
So in the gloss, you need to find what are the common words, okay, and you need to ignore the stop words. Okay. Okay. Deepa has requested us to wait, so we'll wait for a few more minutes. Okay. Okay. I think we can discuss now. So let's hear from SS Bharti.
In just 1 minute.
Okay. Okay. We'll wait for 1 minute. One of the students has requested. We'll wait for 1 minute. I'll ask you. Okay.
Yes, ma'am.
Okay. So yeah, SS Bharti, would you like to say?
Yes, ma'am. Here, the instruction is given that the stop words don't include the stop words. That's why I have not taken the word here. The common words are exchange, medium, and presently used. And because presently is occurring with use, that's why I have taken, I just calculated it as a 2 raised to 2. Exchange, the word exchange is occurring one time, and the word medium is also occurring one time. Therefore, I took 1 raised to 2 for exchange word plus 1 raised to 2 for medium word. And this is how I got the result as a 6.
Yeah. Yeah. That's correct. Um, so would anybody else also like to add on to what she said? So Deepa and Mradul, you also have arrived at the solution. Anything else would you like to add?
No, ma'am. Same reason.
Okay. All right. Let's see. So, as mentioned, so as she mentioned, so we need to see what are the common words in the clause. Okay. So the common words are medium, exchanged, and presently used. Now, what is the formula to compute the score? The formula is we need to see what are the unigrams, what are the bigrams, trigrams, and henceforth. So here we see there are two unigrams, medium and exchange, which are common between the clauses. So that gives us 1 to the power 2 and 1 to the power 2. And presently used is a bigram that is common between both the glosses. So bigram is like 2. So it's like bigram is two words. So that is 2 to the power 2. Okay. And we have similarly, if there was a trigram which was common, we would have taken 3 to the power 2. So in this case, these are the three things. So if we follow the formula, we do the computation, we get 6. So that's the answer. Any doubt? Yes, they have to be consecutive words. Hi, consecutive words, and the order has to be the same. So, so here it's medium of exchange, right? Even if off was not there, had only taken medium exchange, that wouldn't have constituted as a common diagram. It has to be exchange medium only.
It should follow the same order. No?
Pardon?
Actually, in the currency, the metal or paper medium of exchange. So,
Hmm.
the exchange is followed by medium. And the second sentence, the most common exchange medium.
Hmm.
So, medium is followed by exchange. So, the order varies, it's not a problem. The only thing is common word we have to identify.
The order also matters. The order matters. So,
But the order is varying. First, the medium is appearing, then the exchange in the currency.
so that is why we are taking those as to be unigrams. If you wanted exchange medium to be considered as a bigram, as in this case, then those need to be like consecutive words. Otherwise, since they are like they are not following the order, we are taking them to be
Unigram.
unigrams here.
Okay. Thank you.
Yeah. Mm, okay. Any doubts?
Ma'am,
Yes.
here action and medium is taken as a unigram and presently used both together as a bigram.
Exchange and medium. So here the unigrams itself, right? So uh, see here we see that medium is occurring, and here also, and they are common unigrams. So that is why we have taken as them to be two separate. Say consider a different sentence where the sentence would have been the metal or paper medium. The metal or paper exchange medium that is presently used. Okay, in that case, what would you have done? We wouldn't have taken medium and exchange to be two separate unigrams that are common. We would have two set of bigrams that would have been common. So would have been medium exchange and presently used. In that case, the score would have been 2 square plus 2 square. Did that make sense?
Okay.
You have a doubt?
Ma'am, here we are matching the sentence first of currency with the sentence of money.
Yeah.
Yeah, so we have taken the medium as a unigram and action as a unigram. Then if we are finding for the bigram, so we found only the presently used both together.
Yeah.
So we have taken the value 2.
Yeah.
So ma'am, why we have taken the power 2 for this?
So that is as per the formula. So since it's a common bigram, so that is why it's 2 to the power 2. If it was a common unigram, it would be 1 to the power 2. So we are just squaring. If it would have been a trigram, it would be the square 3 square. If it was a quadrigram, 4 square, like that. So the if it's an n grams, it would be n square.
So why we have taken the one to the power? So we have calculated the bigram only for the all things.
No,
I
no.
mean, we have taken here one to power two,
Hmm.
one to power two. These for the medium and actual
Yes.
unigram.
Yes. So
And presently used as a bigram. And
presently.
you have said that for the bigram we take the power two. So for the
Uh,
unigram we have to take on the power one.
so for diagram, the base is 2. The exponent is always the exponent is 2 in all the cases. So always we are taking a square. Only the base is 1 for unigram. Okay. For unigram, n is equals to 1, right? So that is why we have 1 square. For exchange, it's again a unigram. So it's again 1 square. So always it's going to be square. We are squaring numbers. Uh, so as I mentioned, so if it's a n-gram that we have found common between both of the glosses, the corresponding addition to the score would be n square, where n is the order of the n-gram. Is that okay, Vandana?
Yes.
Okay. Okay. Let's go on to the next problem. So here we have this word net noun taxonomy that is given to us, and the values that you see, these are the information content. Okay. And so what we need to do is, so given this word net taxonomy, we need to find what is the limb similarity between house and design. Okay. So this is the first question, limb similarity, house between house and design. Okay. So I'll keep this slide. Remember the limb similarity between house and design. So please try the problem once and we'll discuss it in a couple of minutes.
And can you show the question now?
Yes.
Okay. Go back to the
So only one of you have answered the question till now. Um, how about others? Are you stuck anywhere? Any doubt in the question? So Archana has asked a question. So question is if in both of the glosses, if medium and exchange were in the same order, so it was say here it's exchange medium, here it was exchange of medium, say, okay, and there's a stop word in between. Would in that case would we consider exchange medium as a bigram or two separate unigrams? So it would be two separate unigrams.
That is, it suppose even in the second sentence, even in the money statement also, it suppose the order is same. That is, it is again giving the medium of exchange. Then the order is following, the order is same. So if you remove the stop words, you can consider as diagram.
So it has to be so here also the stop words needs to be present. See here if it is medium of exchange and here it's simply medium exchange, then that won't count. So here also it has to be medium of exchange itself.
Okay, okay. So in both the places, if stop words is there, then we can remove the stop words and we can consider as diagram.
Yes, yes.
Okay. The stop words can be different, or it should be
It
same
should be
stop.
same. It should be same.
Should be same. Okay. Thank you.
Yeah. Um, so how about this question? Um, okay, we'll discuss this. Let's see. So SS Bharti has answered. So option D, I think, right? So could you please explain how did you come to the solution?
Madam, for link similarity, the formula is 2 log P LCS of C1 and C2 divided by log of probability of C1 plus log P of C2. Right? So
Yes.
here, artifact from the figure, you can see that artifact is the uh, head of house and design.
Okay.
That's why I multiplied this 4.70 by 2.
Okay.
Then I divide it by information content of house plus information content of design. That is 11.09 plus 8.75. And we got this result 0.47373792.
Okay. Yeah, that's correct. Um, so maybe we can discuss facial solution ones as well. So as she mentioned, so this would be the formula. So this is the formula of the lens similarity. So in the numerator, what do we have? We have 2 log of p LCS of C1, C2. C1, C2 are the two concepts. What is LCS? LCS is the lowest node in the hierarchy that subsumes both C1 and C2. It's like a common ancestor sort of thing. Okay. And in the denominator, I have log of P of C1 plus log of P of C2. Okay. One thing to note over here is it won't make much of a difference, but still, in the question, what we are given here is we are given the information content. Okay, so these all values of the information content, and here the formula that was there in the slides, it is based on the probability, the content probability. So how is information content that is IC of C and the probability, the content probability is related. So IC of C is minus log of P of C. Okay. So similarly, even if we use information content instead of log of P, we'll have the same formula. So we'll have this. So we'll have 2 times information content LCS of C1, C2 divided by information content of C1 plus information content of C2. So if we see, so what are the two concepts that we have here? It's house and design. What would be the LCS? It would be artifact. Okay. So in the numerator, so we have twice the information content of artifact, and denominator we're summing up the information content of the two concepts that we have. So that's house and design. Okay. So then we are simply just plugging in the values that we have in the Wordner taxonomy. So it's 2 times this divided by this plus this. So what does that give us? So we get approximately the value of 0.473. So that's the answer. Anybody has any doubt in this? Okay, I hope it's clear. Mm, let's see. Next problem is this. We need to find the resonant similarity between building and door. Okay. So again, based on this graph. Okay. So this is very similar. Now that we know what is the lens similarity, resonant similarity computation would be very easy. So I expect most of you to try and pose a solution this time. So you have to do based on this graph the resonant similarity between building and door, right? One second. Yeah, resonant similarity between building and door. That was the question.
Once they'll be providing a formulas and question.
I don't think so.
Also, this log base is getting changed here.
Here,
Yeah, in rasters and distributions, might be the reason base log base to many other places.
so usually we take log to the base 2 only, but if there's a change, it would be mentioned in the question, like it's here, like it is mentioned over here. Okay. By default, you can consider 2 only. Okay, let's discuss the question. So, three of you have answered. Mm, okay, let's hear from maybe let's hear from Archana this time.
Yeah, so the formula is nothing but IC LCS C1 comma C2. So that is the lowest common subset of the building and road structure. So that is just above parent of building and road. So the probability of the structure is 8.20. So that is
Yep, that's correct. So let's just discuss the official solution once as well. So, as she mentioned, so the formula is this. This is the formula. So here we see between building and door, the lowest common subsumer is structure, which has the information content of value of 8.3. So that gives us the resonance similarity of 8.3 in this case. So that was this was an easy problem. Any doubts? Anyone?
Ma'am, will you go to the question?
Yes.
On the tree that we have given. Yeah. If we have given the question, find out the Ramsey similarity between the house and structure, then what will be the answer?
House and structure.
Yeah.
So in that case, you need to find what is the again the LCS. So in that case, again the LCS would be structure itself. So it would be 8.3 again. Okay. So
Okay.
you were wondering
Uh,
whether it would be structure or artifact. That was your doubt. I mean, I understand this can be confusion, but it would be this only.
so if we go to the building and design, then artifact uh,
Yeah,
value.
yeah.
For, okay. So we will go to the, so it can also be the 2.79 is it not?
You can. So if you ask, acha, uh, so 2.79 cannot be. So object cannot. So if you see, so it could be for some other case maybe where you're saying maybe if you had a much more expanded wording taxonomy and you're saying maybe what is the distinct similarity between artifact and some other word X, where the common subsumer, lowest common subsumer is object, in that case it would be. But in this hypothetical one, I don't the artifact is the one which is for the maximum case for all the words. So, is that
So we check the root word itself. I mean, two, uh, two leaves are connected to the root word, the parent node for that, for those nodes. We will check that.
yeah, it's like a you can think of it as like a common ancestor, which is like common parent node uh, in the tree. So for like house and design, as you mentioned, it would be artifact. For house and apartment, it would be building, like that. For house and door, it would be structure. Okay. For structure and decoration, it's artifact, like that. What is the common node?
Okay.
Yep. Any other doubt?
Ma'am, I did not get that answer, ma'am. Actually.
But
How do we check it, ma'am? I use this minus log probability of LCS means which value we have to use.
so LCS is LCS is the lowest common subsumer. So if you are given two concepts, C1 and C2, you have to see which is the lowest node in the hierarchy which subsumes both of the concepts. So here the concepts are that of building and door. So if you try to see what is the LCS of building and door, so that would be structure.
Okay. Okay, that
Sorry,
we have to confirm.
building and do is structure. Yeah. And now here the values that are given is this is the information content, the number that is in bracket. So you have to use this formula, the information content formula.
Okay.
This is when the probability, so if the content probability was given, then you have to use the second formula. Any doubt?
Okay, no problem.
Okay. All right.
You have mentioned that in the question, right? Whether it's IC or it's probably.
It's mentioned in the question. See, then with their information content is shown in figure. Okay. Okay, cool then. It's clear for everyone. Okay. Okay. Next question is this. So now we need to find the this similarity between building and design. So again, very similar problem. Please try once. And we'll discuss in a couple of minutes. Okay, let's discuss. Um, so two of you have answered. Let's ask Mradul. So Mradul, would you like to say how did you solve this problem?
Yes, ma'am. Ma'am, I just use that formula. That as is similarity is equals to minus log of path length of between C1 and C2 in two contexts, and divided by 2 times of length, which is the depth. So if we see that tree, then we will find that path length will be from starting from building design. We will see that we are going from the path length will be 4 here. So path length will be 4 and depth here is 5. So 2 times of 5, which is 10, should come out in the denominator. So after plugging all these things in the formula, we'll get that 0.39 or 0. Something or something like that. 0.39.
Okay, yeah, that's correct. All right, let's check the official solution once. So yeah, as mentioned by Mridul, so the similarity formula for its similarity is this. So minus log of path length between C1 and C2 divided by 2 of D. What is D? D is the maximum depth of the hierarchy. So what are the concepts over here? It's building and design. So what is the path length between building and design? So 1, 2, 3 and 4. So there are 4 edges. So that is the path length is 4. And D was the maximum length of the hierarchy. So what is that? That will be 5. So this, if you see my mouse cursor, so this and this. So that is 5 edges. And this is the maximum depth of the hierarchy. Then we simply plug in the values and we get this minus log of 4 divided by 2 times 5. And we get this formula. And remember, the log is to the base 10 as mentioned in the question.
How this five the distance the maximum depth has been identified?
So you see, so this you see how so object to artifact, this is one edge, then artifact to structure, structure to building, building to apartment, apartment to students. These are 5 edges, right? 1, 2, 3, 4, 5, and that is the maximum depth.
This from the root till the last leaf node we have to consider.
Yes, yes, yes.
Yeah. Okay.
Yes.
Ma'am, but how do we got two, ma'am?
So 2 is there in the formula. You see, the formula is this 2 times D.
Oh, okay, okay, that.
Yes,
It's that.
yes. Any other doubts? Yes, Deepa has raised her hand. Yes, Deepa. Deepa, do you have a doubt? Okay. Okay. Others, any other doubt you have?
No, no.
Okay.
Excuse me, ma'am.
Yes.
Actually, I missed the part where did that four came from.
Okay. So 4 is the, so you have to compute the path length between the two concepts.
Okay.
So the two concepts here are building and design. So if you look in the graph, so building is here, design is here. So these are the 4 edges that is connecting building and design. So that gives us a path length of 4.
Okay, okay, got it.
Yeah. Ashutosh is also asking how to compute path length. So I just mentioned. Should I repeat again? So C1 and C2 are the two concepts that we are considering over here. So here C1, C2 is building and design. Path length is the number of edges that is connecting the two the two concepts. So here it's building and design. So there are four edges. This is 1, this is 2, 3, and 4. So that is why the path length between building and design is 4. Let's take something else. Say between house and door. Okay, now we are dealing with these two concepts. What would be the path length? So 1, 2, 3. 3 would be the path length. Actually, the number of edges that you need to traverse in order to connect these two concepts. Similarly, between structure and design, there are again 3 edges, so the path length would be 3. We are considering the value of the edges. We are considering the number of the edges. The edges, they don't have value. They're unweighted edges here. Okay. Hope it's clear. Any doubt? As we go on to the next problem, I think we can go on to the next problem.
Ma'am,
Yes.
these values will be given in the question.
These values would be given. The tree would be the coordinate sort of tree would be given to you. So either the content probability or the information content would be given to you, and from that you have to do the calculation. Okay.
Okay, ma'am. And ma'am, what is the value of IC? Means IC is what?
IC is the information content.
Okay.
So the information that is associated with the concept, that would be the information content. So the formula is this actually. So if you have the content probability, okay, from that you can compute the information content by simply taking negative of the logarithm of the probability. Okay, so either one of them would be given to you. Either P of C would be given or IC of C would be given. And after that, then you just simply have to plug in the values.
Ma'am, they can be given also the frequency in place of probability.
Frequency, they
Means need to calculate the probability once when we calculate these solutions.
so for that also, so if frequency is given, that would be a bit so in the slides, sir has gone by that only. Sir has shown that how to compute the content probability. For that, for each of the concepts, you need to see how many number of times the concept is occurring in the corpus. Okay, and then you can have the frequency corresponding to each of the uh, concepts. If that is given, then you have to check the root node. Okay, for the root node, there will be a frequency given here as well. From that, you have to further compute the probability. And for that, for each of the frequency of the concept, you have to divide by the frequency of the root node, and that would give you the probability, the content probability. So that can also frequency. I don't. It's not very likely to be given, but if it's given, you can compute the probability, you can compute the information content. So yeah. Mm, is that clear?
Yes,
Okay. Let's go on to the next problem. Yeah. So here we would be doing words and disambiguation. So here we have been given two hubs, colors and lamps. These are the two hubs. This is the graph. We'll come back to this in some time. And what else is mentioned? So we are taking the distance between two words as the path length between them. This is also mentioned. Okay. So let's see the first problem. We need to compute the scores for the hub for between first is between the hub colors and the component white, and between the hub colors and the component fixtures. Okay, so that was the question. This is the graph. Um, 1 second. One thing I'll do is So this is the graph. I'm pasting the question in the chat as well. Just yeah, pasted the question in the chat. Following the graph, you need to solve it. Just try once. We'll be discussing in 1 or 2 minutes.
Ma'am, can you please show the options?
Yeah. Yes. Okay, let's discuss the problem. So one of you have answered, Mradul has answered. So Mradul, how did you come arrive at the solution?
Actually, I don't know the exact method to solve it because I haven't studied it. But I'm just following the formula which is present, which is given in the slide. So in the lecture slide. Score formula that was given is it is equals to 1/1 plus d means that I think distance between HK and WJ. So I guess here it will be valid for ancestor. So that first part which is color and white they are the ancestors. So I guess distance would be 1. So 1/1 plus 1 would be 1/2, which is 0.5. So 0.5 will be there. And for second part, it is saying that 0 otherwise. So I think for second part it will be 0. So none of the above would be the answer. But I'm not sure.
Okay, okay. So yeah. So yeah, you're actually correct. So this is the formula as Madhul said that so SK the score value was 1 by 1 plus D of HK comma WJ, where HK is the half, WJ is the sorry, WJ is the corresponding word and the distance between them. So what is the hub over here? The hub is colors and the component is white. So let's see what is the distance between colors and white. So they're connected by a direct edge. So the distance would be 1. So here, if we plug in the value, we have 1 by 1 plus 1. So that gives us 0.5. Whereas, so here the condition was that the hub has to be, the hub word has to be an ancestor of the component word. Okay. Now, if we see colors and fixtures, that condition is not maintained. So colors is here, fixtures is here. Colors is not an ancestor of fixtures. In that case, we have the value of 0. So that is why the answer of the second part is 0. So 0.5 and 0. So that's the answer. Is this clear?
Yes, ma'am.
Okay. Let's go on to the next problem. The next problem is we have to compute what are the scores for the hubs itself this time. So there are two hubs, colors and lamps. For that, we need to compute the scores. Um, so let's just take 1 minute to so that you all can try, and then we'll discuss. I posted the question in the chat, and this is the graph. Please try once. This is very similar. Just the formula that you saw, you have to use it for every word that is there, and then you just have to simply sum it up for the hubs. Okay, that is how you solve this problem. So I've given you a hint. Just try once and we'll discuss in a couple of minutes.
Then do we need to just some of these codes for colors and length?
Yeah, yeah, yeah. Okay, let's discuss. So this time, two of you have answered. Let's hear from SS Bape. Would you like to say?
Madam, you told us about the formula S2 is equal to 1 upon 1 plus distance between HK and WJ.
Hmm.
For colors node, there are uh, five five nodes are connected to colors, and for each node, I'm getting 0.5. And if we add those values, that means zero point 0.5 plus zero point 0.5 5 times, we get 2.5. And three words are connected to lamps, therefore we get 1.5.
Hmm. Yeah, that's correct. Okay, let's see the official solution once. So this is the formula. Please keep this in mind. So based on the formula, we see that so each of the component has a score of 0.5 as mentioned. Um, you see over here. So you have to compute the scores for each of the words that are there. Okay. So you see for beam, so colors and beams, there's only one edge. So the formula would be 1 by 1 plus 1, so 0.5. Again, for all these, it would be 0.5. So when we consider this hub, okay, so colors is one hub. So all these five words would have a value of 0.5. These would have a value of 0 because they don't share the ancestor, right? Similarly, when I'm considering lamps, these have a value of zero point 0.5, these have a value of 0. So what do I get? 5 times 0.5, that is 2.5 for the hub colors. And for lamps, we have 3 times 0.5, that is 1.5. So that gives us our answer, which is option C. Okay, I hope it is clear.
Ma'am, could you just say again how we arrived at 0.5 for each node, please?
Yes, yes. So if you see this formula, so how do we compute the score? It's 1 by 1 plus the distance between the hub and the word. Okay, so in this case, if we consider say this, okay, say what is, so the hub is colors and the word is white. If we need to compute what is the score, what would we do? We will see what is the distance between the two words. The distance is 1. Because how do we compute the distance? The distance is between two words is the path length between them. So the path length is 1, the distance is 1, so 1 by 1 plus 1 is 1 by 2, which is 0.5. And similarly, if you compute the value for the other words such as beam, shades, prism, dispersed, those would all have a value of 0.5 because the path length would be 1 in each of the cases.
Okay.
Okay. So we're running out of time. We have one more problem for today, which is a continuation of this. Let's just quickly discuss that. So now, given that we have done all of these things, we need to say what is the most appropriate sense for the word light. Okay. So how do we answer that? We just computed the scores for the light is this word. It had these two hubs. For this hub, the value was 2.5. For this hub, the value was 1.5. Which hub has a higher value? Colors. So colors would be the answer in this case. Okay? So since colors has the highest score, in this case, the most appropriate sense for the word light would be colors. That's the answer. Does anybody have any doubt?
That really show the answer.
Yes. We still have a few minutes. So anything?
Ma'am, I have a doubt in week 8 lecture.
Yes.
Week 8 lecture number 2.
Yes. Ask the doubt.
Ma'am, for it, you need to open that slide, that lecture slide.
Yes. Tell me. Open the
Ma'am, the word net therapy.
WordNet hierarchy. Do you know the page number by any chance? This you're saying?
Yes, ma'am.
Yeah.
Ma'am, in this slide, they had mentioned, they said that four senses of mouse. So, ma'am, what are the four senses of mouse? Ma'am, these four senses means four meanings of mouse. So, what are the meanings that they are considering? Like four meanings, what are they?
So here they have only shown two. So there would be, here they have only shown sense 1 and sense 4. There would be two more, sense 2 and sense 3, which is not here in the slide. So you want to know what are the other two senses of mouse?
No, ma'am, actually, it is just confusing me that what are the other two senses? Is it given or is it in that?
So it's not there in the slide. So yeah, if I have to answer, even I have to search once. So I don't know all the four senses. Um,
No, no problem.
yeah. I think these are the most common, the ones that are given here, no? Rodent and mouse. These are the most common ones. Um,
Ma'am, can't there be some more senses with respect to mouse? I mean, with time, the related meanings will be there with respect to mouse.
um, possible. That can be possible. Um,
When we refer Cambridge dictionary says that mouse refers to a shy, quiet, and nervous person.
okay, so that could be another sense. That could be sense number 2. We have three senses. Even I am also searching. I only found these only. Um, I think yeah. So maybe you can check the WordNet. So this is from the Princeton WordNet, right? So you can check over there what else are the meanings that are there that you can do once.
Ma'am, which coordinate?
Princeton WordNet. It's mentioned. See, so if you search WordNet, no, see this is the URL.
Okay, ma'am.
So SS Babu has a question. What is the difference between distributional semantics and lexical semantics?
Now, it also refers to a dark colored swelling caused by a flow. For example, we call it as a black liner. That is also called as mouse
Oh,
excess.
okay. Yeah.
It is in the Merriam-Webster dictionary.
Okay, nice. Okay. So we got the four senses of mouse. That's cool. So just one last question that SS Bape asked. What is the difference between distributional semantics and lexical semantics? So in distributional semantics, we operate at the level of vectors. So we would have vectors representing two concepts, and then we maybe if you want to find the similarity, we would be computing similarity at the level of vectors. Whereas in lexical semantics, we are mostly uh, concerned with the lexical relation. like the ones that we discussed in the beginning, like say hyponymy, synonymy. So here we would be dealing with wordness and knowledge bases like this. That would be the difference. Mm, So yeah, I hope that clears your doubt. Um, yeah, okay. So I think if so, I think we can conclude today's session. Okay. So thank you everyone for joining. We'll close the
Thank you.
session.